In this video, we're going to go over logarithms. So we have to understand the laws of logarithms as well as get to solve some practice problems to help us understand basically what logs are all about. Okay, so first thing that I want you to know is when you have a log of AB, of course in this case what I mean is it's a product of A and B. So you have log, in short you have A being multiplied with B. Okay. So we have a multiplication there of two logs. Okay, so basically this is something that you're supposed to know, that basically this is equal to log of A added with what? Added with log of B. Okay. So that is the first law that we have to understand. So whenever you have a product of two digits, two numbers, that is what you have. So what this means is, by an example, would mean that, for example, in a case where you have log 10. Log 10, basically we understand that log of 10 is basically, or we know the product of 2 and 5 is basically equal to 10. So therefore we can say that that is equal to log 2 plus log 5. So if you get your calculator, you say, okay, log 10, and then you say log 2 plus log 5. You should be able to get the same value there. Okay. Which is basically supposed to be a 1, if I'm not mistaken. Yeah. So that is the first law of logarithms that we have to understand. Whenever you have a product, basically the sum comes out there. Then the other thing, let's say now if we have log of A divided by log of B. So log A over B, in such a case, that is basically equal to log of A subtract log of B. So it's that easy. Okay. In this case, example that we can give is when you have a log of maybe, let's say, 10 divided by 2. This is basically going to be equal to log 10 minus log 2. So meaning that if you get to your calculator and say, okay, we know 10 divided by 2 is 5. So log of 5 is basically equal to log 10 minus, so that is not a base there, so log 10 minus log 2. Okay, so that is so we've talked about two laws so far under logarithms that you have to know. We've talked about the products and also the division. So we've seen what they change to in case of where I get to split them. Okay. Then the other thing that you have to understand in terms of the powers. Okay. So when you have the log of A to the power n, for example, you have log A to the power n. That is basically the same as, so you can take the power to the other side. So it's basically going to be n log of A. Okay, so let me try to give an example on that so that you get to understand more in details. So basically what we are saying is this. When you have, for example, log 2, let's say log 2 to the power maybe 4. That is basically going to be 4 log 2. That's the point that we're trying to make there. And this takes us to the next logarithm row, which is basically when you have a log of A with a 1 there at that point. What is it? So we need to understand that is equivalent to a 0 from this very law. How? Because what we are saying is when you have a log of n, so where there's 1 there, you can put any digit. So preferably we can put the base that we have A. So you know that when you raise a to the power 0, it's basically equal to 1. So somebody who I say that, and with me saying that, we are basically one and the same thing. But going back to that law, it's going to be 0 log what? Log A there. Okay, so by the way, what you have down there is called the base. Okay, so that is the base there of a logarithmic function. So now that we have that, let's try to introduce another law. So whenever you have a log of A, so whenever you have the same base there with a value that is on top there, this is basically equal to a 1, and you should know that. So the fact that that is equal to 1 whenever you have the same base, so if this is equal to 1, this proves the fact that whenever you have a log a1 is equal to 0, because what I'm trying to do is I'll just now, where there's a 1 there, I can just put at the power 0, and if I get to express it in this form, that's what I'm going to have. And what is circled there is basically going to be a 1, which is just going to be a 0. So these basically are the laws of logarithms that we have. So from the laws of logarithms that we have, let's try to look at some of the practice questions before it gets to look at more logarithm laws, as well as change of base. Let's try to look at some of the practice questions. Okay, so let's try to simplify that. So you have log 3 9. So this is your base. Okay, understand that what you have there is basically your base. So what are we trying to say? So simplifying that, so we've said whenever you have the same base, this is equal to a 1. So we want to take advantage of that law. So in this case, our y is going to be, so this is going to be log, so our base is 3. I would want to express 9 in terms of 3, the power 2. At that point, we also know that we have one logarithm law which tells us to say that whenever you have the log of maybe to the power n can go the other side there. So in this case, that 2 can go the other side. So we have 2 log 3 3. So we were also introduced to a law where we are saying whenever you have the same base with a value, it is equivalent to 1. So in this case, this is equal to a 1, and therefore our value of y is just 2 in the first case. So we simplified it there using the logarithm laws. Let's try to look at the other sides now. How do you get to simplify it? So in this case, it's kind of different. Okay, it's not as direct as this other part. So we would also want to establish the same base there so that we can simplify it. So that is basically equal to log 9. So 3 is basically the root of what? The root of 9. So I can say that, okay, 3 is the same as the root of 9 there. So that is equal to the 3 there. What I've put on the next stage, the root of 9 is equal to a 3. But we also know that whenever you have a root of, for example, 4, it is the same as 4 to the power 1 over 2. And we would want to do that. So let me just create some space now. We see what we're going to have. So I'll continue from the left hand side there. So we have our y being equal to log 9. So we are saying the square root of a number is the same as what? It being raised to the power 1 over 2. So another law tells us to say that the power can be taken to the left hand side, which is going to be 1 over 2 log 9 and 9. So we are the same base with the value there. So this is equal to 1, and therefore y in that case is just basically equal to 1 over 2. So from this this concept, this introduces us to another law. Okay, so in this case, let's try to take note of our answer, which is 1 over 2. Okay, so what I want you to know is another law is when you have basically a log of I'll look at the same one, 9 and 3. So I want you to know that this is the same as 1 over, I can change the base, exchange the base with a value there, so it's going to be log 3 and 9. So that is another law that you have to understand there. Okay, so remember that solving it normally, we found our y to be equal to 1 over 2. Let's try it using this principle where I'm saying it's actually a reciprocal when you change or exchange the base with a value. Remember, we've exchanged the 3 and 9, so it's reciprocal. It's actually the same. So we have 1. We know that log 3 and 9, we can express it in terms of log 3, we have the same 3 there, then to a power 2. So that 2 can be moved to the left, and I can remove it from that point. So we know that whenever I've got the same base, it's basically a 1. So we just remain with the 2 there on the denominator, which is basically equivalent to what we found using the normal formula of the powers there. Okay. So we have some more practice problems on the logs. This time around we have log 7, then 1 over 7. So I believe by now you understand that when you have 1 over 2, 1 over 2 is the same as 2 to the power negative 1. Okay. Then I believe you also know that 2 to the power 2 is the same as 1 over 2 to the power negative 2. So what we're trying to say is, whenever you change or come up with a reciprocal of something, it basically gets to change the sign of the power. Meaning that if you have 2 to the power negative 2, it becomes 1 over 2 to the power 2. So meaning that the moment you introduce a reciprocal there, the sign changes. Okay. So what point are we trying to make there? So when you have 1 over 7, 1 over 7 is basically the same as 7 to the power negative 1. We understand that. So at that point we understand that the same base there, this property gives us a 1. So what we have is the negative can go the other side, so we have negative. Then we have log 7 and 7 there. So this is equal to a 1. So our answer is just going to be negative 1 for the first part of the question. Moving to the next problem there, you can try it out from the basics that we've talked about so far. In this case, obviously, we're supposed to find the value of x. So how do you get to do it? So another law of logarithms is going to be introduced from this problem, meaning that whenever you have the log of base a, maybe let me use b there, is equal to, for example, x. So that can also be rewritten by taking away the base. This base can go the other side, and it can basically come out to be b is equivalent to a to the power x. So I want you to understand that. That is also another law of logarithms. So with all the laws of what we've talked about, I'm sure they are very, very enough for you to be able to work out some problems on the logs. So going back to our question there, so what we are saying is this can go the other side and it will become the value there. So we're going to have 81 is equal to x to the power 4. So what is on the right hand side becomes the power. Okay. So I believe this is an exponential function that we are all aware of. So basically we have x to the power 4 there. So we want to find the value of x. So another way of solving such a problem where you are unable to make the base the same, what you can do is try to make is it possible to make the powers the same, since we can't make the bases to be the same because of a variable x. So we know that 3 to the power 3 is basically 27. If you make it a 4, 3, so 27. Let's try to make it a 4 there. So what happens if you make it a 4? So 27 by 4 is basically going to be 81. So 81 can be expressed in terms of that power. So 3 to the power 4 is equal to x to the power 4. So we basically have the same powers there, and we can therefore make a conclusion to say our x in this case is basically equal to a 3, which we can prove. Let's try it out. So say making a fact to say that, okay, our log 3 there, our value of x is 3. Okay, so in such case we can say, okay, log 3, then our 81 is basically 3 to the power 4. The 4 can go the other side, and what we're going to mean with this side is going to be equal to 1. So our answer will just be a 4, which is on the right there. Okay, so we have some more problems there to look at. Okay, how about this case? Of course, we very much understand how to go about it in this case where you have 8 there. We understand that in this case what you just can do is only get to look at this part where you say, okay, let's have the same power, the same bases, sorry. So you have 2, then you have 2 to the power 3. So in that case, we know that the bases are the same, x is equal to 3. So those are exponentials. So there are some exponentials that you can't figure out like that. So logs come in to help you or assist you out. So in this case, we can introduce a log on both sides to simplify it. So we have log 3 to the power x, then log 5 x minus 2. So in fact there is no arm of if I was to introduce, if I can be using the short form of log, there is no arm there. Okay, so what we have is we now have, so from the laws that we've learned, we know that the x, which is the power, can go the other side there. So what we can have at that stage is we have x log 3 is equal to the other side. We can do the same. Our power in such a case we have x minus 2. So it's going to move as a O. Okay, so we have x minus 2, then we have log 5. So our goal is to find the value of x. What do we get to do? So I can divide by x minus 2 because I want it to be on one side. Okay, so if I divide by x minus 2, then I do the same the other side. What are we going to have at that point? So what we have is, we have x over x minus 2. What is this equal to? So even before it gets to look at that, I think that is going to make it complicated a bit. So remember, our goal is to make the x a subject. So in this case, we can divide by log 3 first of all. So our x is going to be, so we have x minus 2 in brackets, then we have log 5. So we are dividing by log 3 there. So that's what we've done as a first step. The next step that we can take is we can divide by x minus 2 the other side. So you basically have x, then x minus 2 being equal to what? Log 5 over log 3. So it may not be possible to get to make x the subject in such case. So what we can do is we can just say, okay, plug in that on your calculator, then get to cross that and multiply, then you'll be able to make x the subject of the formula in such a case. So basically this is how far we can move in terms of simplifying it. So if your calculator there, log 5 divided by log 3, you multiply it with whatever value that you're going to find, you can just multiply it with x minus 2. So let's say your value that you find is a 4. So I'm sure if you open the brackets here, you're able to now find the value of x. Okay, let's look at the next problem there. So we have 2 to the power x being equal to a 9 there. So the point that we are trying to make is, in such a case, it is not possible for you to come up with to get to a stage where you can have 2, then raise a certain power which is going to be a 9. We don't know to what power we can raise 2 to give us a 9. At least if it was a 8, we would have done that. But in this case, we don't know. So we just say, okay, let's get to introduce a log again. So we have log 2 to the power x is equal to log 9. We can take x the other side. So what we have is x log 2 is equal to log 9. And therefore, simplifying it, our x is basically equivalent to log 9 divided by log 2. So that is our value of x in this case. So if you want the exact value in a case where your calculators are allowed, you can plug in log 9 divided by log 2. You'll be able to get the exact value of x. Express the following in the form of log 3 and log 5. So with the laws of logarithms that we've looked at, you should be able to express that one in terms of log 3 and 5. Okay, so we basically understand the fact that 30 can be expressed in terms of the products of 3 and 5, right? So basically we can start from what we know. At least we know that log 30 is basically 3 by 10, that is equal to the 30 to start with. Then we want only to see 3 and 5 there. So we also know that 10 is the same as 5 by 2, right? So 3 by 2, 3 by 5 is a 15, by the 2 is a 30. So at least what we have in this case is reasonably 3, 5, and a 2. Okay, so what basically do they want to see? So they want to see 3 and a 5 in such a case. So how do we get to make that possible? Okay, so is there any way that you can do away with the 2 there, or there is no other way? So obviously I might have forgotten log 2 there. Okay, so we can move it. So what we're trying to say is, we've said for a case where you're given anything to deal with multiplication in brackets, we can express it in terms of addition. So this is going to be log 3 plus log 5 plus log 2. So we've broken it down, we've simplified it, we've expressed it in such a form where we get to see the log 3, the log 5, and also the log 2 there. Okay. Let's try to look at the other side of the question there. So when you look at the other side of the question, what we have is log 450. So we want to express it in terms of the product of 3, 5 there. Okay, so at least we know that log 450 is basically the same as, so 450 is the same as 45 multiplied by a 10. And we also understand that basically 45 is the same as 9 times 5. Okay. Then we also know that 10 is the same as 2 times 5. So we still want to see, we only want to see 3, 5, and 2 there. How do we make it possible? So we also know that log 9, so we have 9 there. 9 is the same as what? 3 by 3. Or the other way that we can show it is, let's make it simple. 3 to the power 2. Then multiply by 5. So we have 2 5s as well, so it's 5 squared by 2. Okay, so from that stage, what can we do? Okay, not forgetting log 2 there. So what we can do at that stage is we can distribute the log. So whenever you're dealing with multiplication, we say it is going to be, so the first part is log 3 to the power 2 plus log 5 to the power 2 plus log what? Log 2. That's what we have in such a case. So from there, what can we do? We've learned about the power rule under logs here, so it can go the other side. So that is basically going to be 2 log 3 plus 2 log 5 plus log 2. And that is the simplified form of log 450. So in other terms, somebody may argue to say, okay, I would want to use a different way. So where we say that, for example, where we get to say log what? Log 9. So if you want to express it in terms of 3, you can also say it's basically 3 by 3 instead of saying 3 to the power 2. So we can't argue. We can say log 3, again you had log 3. Since these are the same, it will still end up becoming 2 log 3. So whichever way you get to use, you still get to the same solution. Find the value of x. So we now have an equation. We want to find the value of x. Okay, a full equation there. So using the laws that we've looked at, let's try to solve this question. So find the value of x given that the log of x minus 1 plus that is equal to that. Okay, so without even wasting much of your time, in this case what we are looking at is a fact that we have an addition in between there. So whenever you have the same base here, so we have log. So whenever you are dealing with addition, we said you can multiply what you have. So in this case what we have is we have x minus 1 and x plus 2. So the law that I'm using is when you have the log of a plus log of b, this is the same as log what? ab. So you just get to multiply what you have. So on the other side, what do we have? So we have 2 log x plus 2. So how else can you express that? So we can say that 2 can go back there as a power. So you have x plus 2 the power 2. So you can basically see that the log is basically the same. It's having a base of 10. By the way, whenever a log is not showing any base, it's the base 10. So you can cancel it out. At this point, we understand that, okay, so sorry, that is actually a 1, not a 2. So even without wasting much of your time when it comes to expanding these brackets, we understand that that's a difference of 2 squares. So when you get to simplify it, you're going to have x squared minus a 1 equal to the other side expanding that what's in the brackets. Of course, we understand that you have x plus 2. So whenever it is just a power 2, it means that's what it means. So multiply the x with what's in the other brackets. You have x squared plus 2x. Multiply the 2 again with the other part. So you have again 2x plus a 4. So if you get to simplify that, so you have x squared 2x plus 2x is 4x, and you have a 4 there. So we've simplified it. So our goal is to find the value of x. How do you go about it? So we understand the fact that you can collect the like terms. So this is going to cancel out with that because it's basically the same. So we have -1 on one side. So what can we do? So -1, this can go the other side. You have a -4 is equal to 4x. We have a -5 is equal to 4x. And therefore our x in this case can be equal to -5 over 4. So we simplify that equation and we found the value of x. Okay, just a few more logarithm laws that you have to understand in case you get to meet something that we've not covered here. So what I want you to know is I've said when you have a log, that's a log of x. Whenever we are not showing the base there, just know that what you're talking about is log what? Log 10 x. Okay, so meaning in a case where they've given you a question like, let's say log, maybe log x maybe is equal to 2. They ask you to find the value of x in such a case. So just like we've made a law to say whenever you have a base there, you can take that the other side, the a can go the other side, and it can be equal to b is equal to a to the power c. So this is going to be very applicable, understanding that whenever there is no base here, just know that it's a 10. So it's going to be x to the power 10 to the power 2, which is going to be 100 there. Okay, so that is one law more. One more thing that you have to understand. The other thing that you also ought to understand is the fact that when you get to see a natural log, so a natural log is just equal to a log with a base, the exponential. That's what it means. Okay, so when you have whenever you see a natural log, it's basically a log with a base what? Exponential. That's what you have to understand there. Okay. Then the other thing is you ought to know that basically a natural log is so in a case where they ask you to simplify, let's say you've been given natural log of e to the power x. How do you get to go about it? So you know that the natural log is basically just going to be what? This is going to be a log e. Okay, that's what you have there, log e. Then you have what you have at that point is e to the power x. Okay, so how is that going to simplify out? So that becomes let me just create some space on top here. So this is basically going to be natural log of e to the power x equal to, so we said that can go the other side, it can drop and comes at this point. So you have x, then you have log e, then e there. So we also made a point to say whenever you have the same base with a value on top there, it's a 1. So what point are we trying to make? So we're trying to say whenever you have the natural log of e to the power x, it's going to be equal to a. So in this case, let me put x. It's going to be x. Okay. So that means that let's say you have natural log of e to the power maybe 2. That is basically supposed to be equivalent to 2 from what we've seen there. Okay, very, very important to understand that as well. Then how about a case where we get to make it the opposite? Let's say you have e, then the power natural log of x. What do you have to understand in such a case as well? What are you supposed to understand? So we understand the fact that basically we're not talking about the natural log. It is the same as what? So adding it as a power is the same as dropping it this side, e there. Then at that point it will still be the same. We understand that natural log is a log with a base e there. Okay? We still understand that fact there. So knowing the fact that we have our x there, and we have the product of x and e there. What is that going to be equal to? Okay, so at the end of the day, this is still going to simplify to x. Okay, this is still going to be x as well. So note that as a law as well. Okay, one more thing to understand is how we get to change the base of logarithms. Okay, so if you have a log, let's say log a, base a, then you have a b. If you're trying to change the base, let's say you want to change to make maybe make a new base, maybe c. What you can do is you write two logarithms with the base c. Okay, then divide them. So say log, again a c there. So now, where are the b and the a going to be? So basically what you need to understand is the b will maintain the top part. Let me use a different color there. So then over what? A. So it's basically going to be the log of that new base of b over what? A. So that is how you get to change the base of a logarithm. Let's look at some examples. Let's say you have log 7. Then I made a fact to say whenever the base is not shown, then you're talking about base 10. So let's say they ask you to change the base to e. So I've made a fact to say natural log is actually a log with what? Base e. So in such a case, how do you get to move to that? So we have to understand that what is going to be. So the base that we're having is log e. Then over what? Over log e. So what do you have as your base in this case? Your base is a 10 there. So it's going to be 7. Then down you have what? You have a 10. So we also know the fact that a log with base e is basically a natural log. So what you're going to have is basically just natural log of 7 over natural log of 10. That is one way in which you get to change the bases. Just one more practice problem there on how to change the base. Now let's say you have a log of 6 to 12 here. Then they ask you to change the base to 10. Change to base 10. How do you get to go about it? So all the same, we'll say the new base 10, again log base 10. So then that will be maintained on top. Then we'll have a 6 down there. So that is the way you get to, that's how you get to go about it whenever you're looking at a point of trying to change the base. And of course we get to understand that by the way that whenever you're trying to divide, basically it's the same as we can express that in the form of log 10. Then since we are dividing there, we have a 12, then being divided by log 6 there. So factoring out the base, you basically have 10 or 12 over a 6 there. Okay, which is basically going to be log what? Log 2. Okay, so that's how you go about it when it comes to the changing logs and the logarithmic functions. So that's it for this video. I just hope that you now know how to deal with different logarithmic questions and how to go about them. Thank you very much for watching.